very good afternoon to everyone. And my name is Aditi Desmukh, as you can see here, and I am a student of MSc Physics first year. And the topic I am going to present today is Lagrange's interpolation method. Now, why do we use Lagrange's interpolation method? This could be a question. Because there are many methods which we can use. As you can see, this is the Lagrange's interpolation formula, and you can see it starts here and ends at this by 4. We have taken 4 sums here. Okay, so we are basically using Lagrange's interpolation theorem in the cases where the difference between the x terms is not uniform. Lagrange's interpolation formula is only applicable when there is non-uniformity in the questions like this. For example, as you can see, I have presented an example here. Here we have the question: evaluate under root of 155 by using Lagrange's interpolation method. This is our question here, and here there is a table given. We have to evaluate the value of under root of 155. We have given the values of x and y equals to under root of x. Our main motive is to calculate the value of y equals to under root of x by using Lagrange's interpolation formula. So without any further delay, let's get ahead. And as you can see, in this x column, there is x1, x2, x3 and x4. Now as you can see, the difference between these two terms are 152 minus 152, 154 minus 152, again 2, 156 minus 154, again a 2. You can see there is a uniformity in this, but I've taken this example and coincidentally this have uniform difference between them, but you can also use this for a non-uniform sum. And here the value of y is also given to us, y1, y2, y3 and y4. It doesn't matter even if the difference between the two terms are uniform here. And so let's get to a solution which is very simple. All you have to do is you have to remember this formula, which is not at all tough to remember this formula. As you can see here, y of x equals to y1 into x1 minus x2. It's not x1, it is x. And you all must be wondering what is x. So x is the value here, 155, which I have written here in case you missed. So y1 and 155 minus, what is the value of x2 here? 152. So as you can see here. So first let's get to the formula. Y1 into x minus x2, x minus x3, x minus x4 to the denominator of x1 minus x2, x1 minus x3, x1 minus x4. Now, itna portion if you have learned now, the further 3 additions are not at all difficult. y2, y3 and y4 terms are also very simple. The upper term, which is the numerator, will always be same, that is x minus x2, x minus x3, x minus x4. The numerator will be same for all the 4 additions. Now for the denominator, in the first case we are taking x1 minus x2, x1 minus x3, x1 minus x4. And in the further 3 additions, the second terms will not change. Only the first term, which is x1 and x2 and x3 and x4, will be changed. Now getting to the solution, now we have to solve this example. For solving this example, you have to first write the value of x, which is 155, which is already mentioned in the question, and then you have to copy this Lagrange's interpolation formula, same like that here, and substitute the given values of x1, x2, x3, x4 and the y's respectively. As you can see here, I have already substituted the value for you all in the interpolation formula. So 12.247, which happens to be the value of y1, into x. What is x? 155. 155 minus 152, 155 minus 154, 155 minus 156, and further on. You can put all the values further on from copying from the table to directly here. And then, so the main thing which you have to do while calculation is following the board mass rule. It is not easy to calculate it by hand, or in order to be quick you must use a scientific calculator, accurate answer, and you will also not waste much time here. As you can see, for you all, I have already solved the 4 additions, and the values which happens to come here are 0.7654 and minus 3 of 8246 there, and plus 11.643 plus 3.9031. And by further solving these 4 values, you get the value of y under root of x, which is y of under root of 155, which is 12.478.